Hi, I'm Quincas and I'm a synth DIY guy. And this is the Contour 1 by Joranalogue Audio Design or Joranalogue Audio Design. It's a slew generator or a slope generator. The original slope generator was the Duo Universal Slope Generator by Surge, and it's a classic module that is beloved by all. I consider a good slope generator to be absolutely essential in any modular system. For me, it's as important as a VCO or an envelope generator or an LFO. In fact, it can do all three of those things depending on how you patch it. And while the maths, the single most popular Eurorack module ever made, is a dual slope generator as well, very close in function to the original Dusk and adds a few things too. And the Contour 1 is no clone of the Dusk or the maths. It is a complete redesign with many interesting and advanced features, including the fact that as an oscillator it responds to 1 volt per octave, so you can play in tune with it. It has a trim pot for fine-tuning if you find that you need to recalibrate it. It has a loop switch that re-triggers it at the end of its cycle. It has a built-in button right here so you can manually trigger it. It has 2 knobs for bend, which basically affect the shape of the ramps, be it the rising ramp or the falling ramp. You can go from exponential through linear to logarithmic response, and there's a CV control for that. The rate controls are sliders, which is really cool because you can move them simultaneously by just grabbing one with each finger, and that's much handier than having knobs for that function. There's also CV inputs for the rates, and they're normalized so that if you stick a CV source into the first rate input, it'll also affect the second rate input, and the same happens with the bend inputs. And down here you have the main input, which you use if you want to slew a voltage, meaning slow down its change. So you can use that to turn a square wave into a triangle, for example. You can use it to create a portamento or a glide effect if you send 1 volt per octave signal there and stick this module between your keyboard or your sequencer and your destination oscillator. And you can control that glide with voltage, which can be super cool. It has a gate input, which lets you use it as an envelope generator, an ASR envelope generator. And the advantage of using the gate input versus the normal input is that it'll guarantee that your envelope level will go all the way up to 10 volts. Same with the trigger input, except that you lose the sustain stage, so it'll just go up and down and won't hold it. And then there's a hold input as well. When you send the gate there, it'll just hold it. It'll freeze the output voltage until that gate you're sending goes low, and then it continues on its cycle. And you have these outputs right here. The main output, there's an inverted output, and there's also a gate that goes high when it's on the rising stage and a gate that goes high when it's on the falling stage, which can be super useful. There's a range switch that goes from full to audio. So if you're going to use it as an audio source or an audio wave shaper or something like that, you can leave it in the audio range. Or if you're going to use it as an LFO or an envelope generator or a glide, you would probably want to use it in full mode. So there's a lot that can be done with this module. Super well designed. Let's start taking a look at some of its functions. First, I'm going to take a look at using it as an oscillator. Okay, now this module, like most slew generators, generates positive voltages. Meaning if I set it to oscillate, it'll create a triangle wave, but one that is not oscillating about 0 volts. It doesn't go negative. Right, unless I use the inverted output, then it'll only go negative. But the normal output is basically going to go from 0 up to 10 volts. So what I'm going to do is I'm going to use the Select 2, which is another Joranalogue module that's doing a cameo on this video. It's a super cool dual CV processor. It can do offsets, it can do mixing, It can do a tenue version. You can use it for sample and hold. You can use it as an externally activated switch to select between two separate inputs. There's just a lot of cool things you can do with the Select 2 as well. And right now we're going to use it just to generate a negative offset so that our triangle wave is centered around 0 volts. So I'm going to put the Contour 1 in loop. So now you see the LEDs light up, right? I'm going to take its output and I'm going to send it to input 1 on channel B of the Select 2. The reason I'm using channel B is because channel A is automatically mixed into channel B. So that means I can use it to generate that negative offset. So I'll turn the attenuator from B all the way up. We'll take that output and we'll stick it in my oscilloscope right here. And there you go. We have a nice little triangle wave there. And as I move both my faders sort of together, you can see that triangle wave maintains sort of its shape. You can also skew it, and obviously that'll change the timbre as well. Let's try to tune it so it's a triangle. That looks pretty much like a triangle wave, right? Yeah, and here's the offset that I'm generating with the Select 2. Right, the top knob here is basically generating an offset. So now the first test I'm going to do is to see how in tune it is. I'm going to use my BeatStep Pro here as a controller. I'm going to send the first sequencer CV output into the rate input here. That's pretty in tune to me. All right, why don't we make a little sequence? I just created sort of a random sequence there. Let's bring that pitch down. So that's pretty cool. And of course, you can change the wave shape by changing the relationship between rise and fall. So this is more like a saw right there. And of course that also affects the pitch, but does it affect the tuning? So let's see. Yeah, it does. It completely affects the tuning. So what that means is that the way that it works as 1 volt per octave oscillator is as a triangle wave oscillator. So when you change it to a different waveform, it also changes the volt per octave response. So that means you can use some kind of amplifier, for example, to change that. If you really want to, you could probably use that volt per octave trimmer and tune it so that it's a saw wave oscillator in tune. Or you can just leave it in triangle. And yes, it needs to be a pretty perfect triangle in order for it to be in tune that way. You can bend that ramp. So I'm making it logarithmic or exponential, and that affects the pitch too, and it affects the sound. It makes it more saw-like, right? And I can do the same with the descending ramp. Now, it affects the central pitch, but does it affect the tuning? So let's check that out. That's pretty close to an octave, right? So if I change the rising ramp to exponential, it stays. That's still in tune. Now let's make it logarithmic. And it's still pretty much in tune. The octave's a little bit flat here, but you can probably compensate. There you go. You can compensate by changing the rate of the descending ramp a little bit. So you can fine tune it by carefully adjusting the bend and rate controls. So let's do the same now with the descending ramp. So now I made it exponential. So yeah, it sounds a little bit flat again. That's better. So this is actually a better way to get a rampish sounding wave and still have it be in tune as an oscillator, is by bending the shape of the ramps rather than making them shorter or longer. So you keep the rates very close to the same value and you bend the shape of either the descending or the ascending ramp, and you can still use it in tune. Now let's see in logarithmic. Again, that's a little bit flat. There you go, that's pretty much in tune. Of course, if you use a tuner, you can be more precise than I'm being right now. So there we go, full range again. Let's get that sequence going. So cool. So that's something you don't normally get with a slope generator, such precise 1 volt per octave response. Cool. So what other things can I do with it? Another thing I can do with it is Portamento, for example, right? So let's now use my filter 8 as an oscillator. So I'm going to take an output from it right here. And there we go. Now the filter 8, I don't think needs that offset because it is oscillating about 0 volts. So we don't need to use the select 2 for that purpose. So now it's just an attenuator. I've centered the top knob to remove the offset. I can give it an offset if I want to. Probably a better idea to just leave it flat like that. Now, what I'm going to do is I'm going to send the sequence from the BeatStep Pro into the Contour 1 input. We're going to remove it from the loop mode and put it in slew mode, and we're going to leave it in full range instead of audio range. And then I'm going to take another cable from the output, which is right down here, and we're going to send that to the volt per octave input of the filter 8. Right? So now I can bring this down and create a Portamento. Now let's compare that voltage that's going through the Contour 1 with it going direct. And it's the same note. So that's another advantage. I have slope generators that detune the volt per octave coming in, which is annoying. If you want to use it as Portamento, you don't want it to go out of tune. You want it to stay in tune and have Portamento. So that's a really nice detail about the Contour 1, the fact that it respects your incoming CV. It keeps it in tune, right? So now, one thing I can do here that can be fun is control that Portamento with the velocity output of my BeatStep Pro. So I'm going to grab the velocity output here, and I'm going to stick it in the first rate input of the Contour 1. And let's start the sequence. Now I'm going to press knobs here on my BeatStep Pro to change it to velocity, and now the knobs they're affecting the velocity. Let's slow down so now I have per step control of how much Portamento I'm using. Let's bring that central pitch a little bit down. Sounds nicer down low right there. So that's super cool, right? You have voltage controlled Portamento. This can be a super expressive patch here because I can control my Portamento now by how strongly I strike the pads. So if I press softly, I have a slow Portamento. If I press fast, you get an almost immediate note change. So with a little bit of practice, I can pretty much decide based on my touch, on my articulation, how long one note will take to change to the next note. And that can be super expressive if you're a player. And of course you can do it like we did just a second ago by using the knobs. Now I'm going to stick it into the trigger input here. I want a nice strong signal. There you go. Right, now that's, if I use the input here, since my Beatstep Pro is putting out a nice tall gate, it's still super loud. Let's use the attenuatable input here on the filter 8 so we can see what the difference is. So this is using the input and this is using the trigger input. Oh, so it looks like the Beatstep Pro is actually putting out a larger voltage than what the trigger input uses, but it standardizes it. So the trigger input standardizes that voltage. Now with the gate's cool because then you have attack sustain release, right? So if I hold my finger on the pad, it'll stay at that top voltage for as long as I'm holding it and then go down. Like that. Right? Which is also the same with the input here. Except that it's a different voltage, right? If the Beatstep Pro was putting out a lower voltage as its gate, then it wouldn't go as high. So the input is dependent on your gate voltage, whereas the gate and trigger inputs are not. Now let me send my second gate from the Beatstep Pro to the Hold here, and let's see what happens. So there you go, I froze that voltage. So let's try again with a slow rise. There you go, I stop it in its tracks with that second gate, and then it continues. Let's try again. So what's cool about that is I can send it maybe a clock, for example. So I have an LFO here from my product module. Take that LFO output and send it to that Hold, and then we'll make it sort of stepped. Now, another thing that I like to do with this module is use it as a wave shaper. In particular, I have this lizard module over here, which is it's an oscillator, which basically is a sequencer running an audio rate, which means you can draw your waves, and I'll show you real quick. You can draw waves by changing those voltages, those 8 sequential voltages. So let's take a look at the, there you go. So as you can see, let's turn this down a little bit. So as you can see, by turning these knobs up here on my lizard module, I can create various wave shapes, but they're always kind of chiptune-y sounding, always kind of like pulse wave sounding, because they're straight segments. So that's already really cool. It's a really cool module. The lizard, it does a million other things besides this. This is only mode 1. But still, I've always thought, how cool would it be if I could make those straight lines be ramps, right? And I've tried using one of my other slope generators for this, but since it didn't respond to 1 volt per octave precisely, it wouldn't maintain the wave shape independently of tuning. So since this one does that, the Contour one, I'm going to try sending that squarish wave from the lizard first into the Contour one, and then take the Contour one output and send it to the oscilloscope over there. And now we need to, there we go. Now, check that out. It's making those straight lines from the lizard module into ramps. So you approximate triangles, right? Now, if I send the Contour 1 and the lizard the same CV, and now I can run this sequence, for example, and I can fine-tune that timbre. Set the Contour 1 all the way up, then you get those square waves again, right? And now I can make just the upward ramp different. And again, I can still change parameters of the lizard here. Cool. There you go. That's more triangular. So far less harsh sounding. Fewer harmonics, right? This is very triangular sounding right here. Let's change the octave a little bit. Let's go up an octave. Right, now I can also change the bend, and that make those ramps less straight, more logarithmic or exponential, and that also changed the shape. Now this is particularly interesting on the lizard module because of how it's made up of 8 different segments. In fact, there's a mode that's actually 16 segments. It goes up the octave, which is the ping pong mode, goes back and forth. That's pretty cool too. Let's turn this up a little bit now, so I can really shape it. Now, even if I use another mode here on the lizard, the next mode is a mode where the segments, the 8 segments, are animated by individual LFOs, and the knobs are now LFO speeds. And so this makes it for a very, very interesting morphing wave. And that's super cool now, as you can watch in the oscilloscope. Again, this is what it would normally sound like. Just a square, right? Very kind of harsh, chiptune, still cool. But as I bring those ramps, as I make those ramps a little bit slower, you can really shape that sound. And again, changing the bend now, bend settings. Now, of course, these bend settings are voltage controllable, so why don't I send LFO to affect the bends. There you go. My audio rate gets kind of craziness, but if I'm using like a slower LFOs, 2 levels of morphing on this wave. One is from the lizard itself, the fact that the 8 segments are moving up and down. And the other one is how I'm bending these. Now, so why don't I use the Select 2 as 2 attenuators for these LFOs here. And now I can fine tune how much of that LFO is affecting the bend settings. There you go. Pretty cool. Now if I change the lizard mode again and go to pulse wave, and I can use a different LFO now. There you go, for one of them. That's pretty cool. So you can create some very interesting wave shaping effects So that's just a square wave that I'm turning into a sort of triangular, morphing triangular thing. Now what happens if I take, instead of taking the main output, I'll take the rise output here. There you go. Now you have a square wave again. Same with the fall. By changing the band here, I'm basically affecting the pulse width. That's another thing, another neat trick you can do with the Contour 1. You can turn any kind of a sine wave or a triangle wave into a square wave. That's almost as a comparator would, right? Because it's these rise and fall outputs are actually gate outputs. Now if I put it in loop mode again, now you start getting into some pretty noisy territory, because it's self-looping as well as responding to the incoming audio. Let's take the output again, the normal output. And I can send a separate sequence to that. Let's go in my sequence 2 here, and we'll take the second rate. So yeah, I have a sequence going here. Pretty cool. If I remove the incoming wave, this is what you get. Like, this is the two separate sequences, one for the rising ramp, one for the descending ramp. And I still have the band inputs responding to the LFOs. Let's make those LFOs a little faster. And we're getting into some pretty crazy territory here. Slow it up again. So that's using the Contour 1 as a wave shaper. Let's put it in audio rate. Cool. So now let's go to the filter 8 as the oscillator. I'm going to put it in audio rate, bring it up there, and let's take a separate output to sync the oscilloscope. There you go. Now I can use the Contour 1 as a voltage controlled LFO, but in some interesting ways, because I can voltage control not only the rate but also the bend, and that's gonna sound pretty interesting when I apply it as an LFO to filter 8 here. So right now we're in audio rate. Let's bring it down to full range. So this is sort of just a triangle, right? Triangle LFO. Now if I send that LFO from the product here to the bend, so now you're getting this varying response, this kind of mutating response. And now why don't I take the sine wave from my MFOS VCO here and send it to the other band input. So there you go. Now we have an LFO that's sort of varying in interesting ways, rather than just being like a straight up siren, right? Now if I take the pitch of my sequencer here and start modulating the rate of the rise, and take the other one and modulate the rate of the fall, now we get some even more interesting modulation effects. Especially if I go up to audio rate now. Now I'm basically sending it audio rate FM that's being shaped by two LFOs as well as two sequencers. You can go up to audio rate on one of these oscillators. We can make the tempo faster here, or slower again. So yeah, as a processor, kind of combining different modulation sources. Oh, that sounds so cool. And you can do some cool things too by just flipping that range switch. So right now it's in full range, but I can momentarily turn it into audio range and then back. And that can be part of my performance. Different kinds of sounds there. And also changing the central bends here. Now look at that, we're getting kind of a vocal formant kind of a sound there. And I can even send yet another sound here. For example, I can take that triangle wave from the VCO here on the product and send it on the into the input of the Contour 1 and check that out. So these are just a few of the really cool things that you can do with the Contour 1, a very special slope generator for Eurorack by Joranalogue Audio Design. Hope you liked it. I hope you liked the video. If you did, click like, subscribe, hit the bell, join my Patreon, and stay noisy. See you soon. Bye-bye.